You are welcome to today's class. In today's class, we are going to be looking at sets. Sets. Set is a collection of objects. A set is a collection of objects. For instance, you can look for the set of students of economics education offering mathematics for economics, statistics, microeconomics and macroeconomics. Looking for the total number of students offering this, we will say that we are trying to identify or to know their set. For instance, 30 students may be offering mathematics for economics, while 70 may be offering statistics, 23 microeconomics and 37 macroeconomics. In sets, there are some things that we have to note in sets. If we have something like S, A, this is called what? X is an element of A. S is an element of A. Why we have this? S is not an element of A. We move ahead. In set, when we have something like this, it is called what? An empty set. This is an empty set. It is an empty set. Now, let's go to example 1. But before going to example 1, when we have something like this, we said it is intersection. And when we have something like this, we said it is union. All these signs, you have to know their meaning very well. When you know the meaning of all these signs, then you will find it very easy to solve questions on sets. We have another sign. This A, this means A without B. A without B. A without B. In this, what is this one? When we have this, a difference in A and B. With all these signs now, we can now move to example 1. In EG1, in example 1, when we say A intersection B, how can we represent this with a Venn diagram? When you are representing this with a Venn diagram, it comes like this. This is it. In this diagram, A intersection B. If here is A, here is B. A intersection B means what we have in A and also we have in B. So what is common? A is like this, while B is like this. So it's only this middle that is common in both. So the middle will be shaded. The middle will be shaded. So this is A intersection B. Where we have A union B, we say A union B. In A union B, we have it like this. This A, this is B. In A union B means that all the elements in A and B, that means all the elements that are both in A and B. So, all will be shaded. So this A. That means all will be shaded. Another one we have A without B. This is called A without B. In A without B, how do we represent this on a Venn diagram? It will come like this. Now, we have this to be A, we have this to be B. This now says that A without B. That means only A, BA must not be covered. And this is where our B is. This is our B. So we make sure that it did not cover our B because it said A. So this is it now. A without B. The next one we have difference between A and B. This means difference between A and B. Difference between A and B. To get the diagram for difference between A and B, we have it. We have A, we have B. The difference between A and B, meaning they don't have anything in common in both, is the difference you are looking for. So you have this shaded. You have only A and only B shaded. This is it now. Only A and B is being shaded. This is difference between A and B. With this now, as we have said, A intersection B, I've explained A union B, A without B, and difference between A and B. Now let's go to another example. Now, we have done something on this Venn diagram. Now, let us use figure and see how it will look like. A question says that, example 1. Example 1 says, using set A equals to 1, 2, 3 and 6, and B equals to 2, 3, 4, 5. Find, Roman figure 1, A intersection B, Roman figure 2, A union B, Roman figure 3, A without B, A slash B, Roman figure 4, B slash A, and Roman figure 5, difference between A and B. Now, we want to work this. Solution. In Roman figure 1 says that using set A equals to 1, 2, 3, and 6, and B equals to 2, 3, 4, 5, 2, 3, 4, 5. Now, A intersection B equals to what is common in both A and B. 1 is in A, is not in B, so it's not common. 2 is in A, we also have 2 in B, so the first common figure is 2. 3 is also common in both, 3, and no any other figure again. So this is our final answer in Roman figure 1. How can we represent this on a Venn diagram? Then we now come here. Drawing a Venn diagram for A and B. A and this is B. Now, intersection means what we can find in A and we can also find in B. What are the things we can find in A and also find in B? This is it. We have 2 and 3. So you come inside here, which this inside here covers both A and B. So you have 2 and 3. And in A, what do you have? You have what left? 2 and 3. You have 1 and 6. In B, you have 4 and 5. So what is pointing to the intersection is what we have here. This is what is pointing to A intersection B, which equals to 2 and 3. This is our answer here. So that is our answer for that. We move to Roman figure 2. Roman figure 2 say A union B. We still have if A equals to 1, 2, 3, and 6, and B equals to 2, 3, 4, and 5. Now, what is A union B? A union B equals to, when we talk of A union B, what we're referring to here is that what are the elements in both A and B. When I'm referring to the element, I'm actually talking about the figures we have inside here, inside the set. So, what are the elements in A and B? We have in A, we have 1, we have 2, 3, in B we have 4, 5, and 6. This is our answer. All the elements in A and B, so we have 1, 2, 3, 4, 5, and 6. How do we represent this with a Venn diagram? You can now say now we have A, we have B. 1, 2, 3, 4, 5, 6. So in common, 2, 3. This one is 1, 6, 4, 5. Now, the difference between what we have solved here and this is that this one, A union B, is talking about all the elements. So now, our answer here are all the 6 elements you have in 1, 2, 3, 4, 5, 6. They are all our answer. They are all what give us A union B, which equals to 1, 2, 3, 4, 5, and 6. Unlike this one, whereby it's A intersection B, where we have only 2 and 3. Roman figure 3. In Roman figure 3, we have, the question says we should look for A without B. A without B. What is A without B? If A equals to 1, 2, 3, and 6, and B equals to 2, 3, 4, 5. So A without B equals to what we have in A that is not in B. What are the things we have in A that are not in B? 1 is in A, is not in B. So we have 1. 2 is in A, is in B. So we don't go with 2. 3, we don't go with it because we also have it in B. And we have 6. So which gives us only 1 and 6. That is why we say A without B. what we have in A that we don't have in B. Representing this with a Venn diagram, we have A, we have B. Now, what do we have in A that is not in B? That is 1 and 6. That is the only thing we have in A that is not in B. So, this is our answer. A without B. So, A without B equals to what? 1 and 6. That is our answer. Now, we move to Roman figure 4. Roman figure 4 says B without A. B without A. Roman figure 4. B without A. B without A, where A equals to 1, 2. Is it 1, 2, 3, 6? And B equals to 2, 3, 4, 5. So now A slash B, which is B slash A, which is B without A. B without A. B without A equals to, what is in our B that we don't have in A? 2 is in B, we have it in A, so it's not included. 3 is in B, we also have it in A. 4 is in B, we don't have it in A, so we have 4, comma. 5 is in B, we don't have it in A. 5. That's why we say B without A. Representing it on a Venn diagram, we have our Venn diagram like this, where we have A and we have B. Now, in B that is not in A, this is our B, so we have 4 and 5. We have 4 and 5. This is 4 and this one is 5. So that means this B not in A equals to 4 and 5. So that is our answer for that. We move to Roman figure 5. Roman figure 5 is talking about A, then we have this sign, the triangle sign. Difference in A and B. The difference, this is talking about difference in A and B. The difference in A and B are what? So we now say A, the difference in A and B equals to, what is in A? If we have our A equals to 1, 2, 3, and 6, and our B equals to 2, 3, 4, and 5. Now, the difference in A and B equals to, what are the difference in A and B? Since both of them have 2 and 3 in common, so what is the difference in them are the number they don't have in common. Which number they don't have in common? We have 1, 4, 5, and 6. So those are the numbers they did not have in common. Representing this on the Venn diagram, we have it like this. A, we have B. In A, we have 1 and 6 that is not in common, and in B, we have 4 and 5. This shows that only 1, 6, 4, and 5 they don't both have in common. 2 and 3 are in common in both, so 2 and 3 will be removed. So these are what we have as our answer. We move down to another example on sets. Now, let's look at this A question says that in a social science department of 32 students, in a social science department of 32 students, a student can either study economics, education, or social study, or both. A student can either study what? Economics, education, or social studies, or both. A student can either study economics, education, social studies, or both. That is out of a class of 32 students. If 16 students study economics education, the question has a, if 16 students study economics education, 16 students study study economics education, 18 students study social studies. Economics education, economics edu, 18 students study social study, 3 study none. 3 study none of the courses. 3 study none of the courses. Find how many students that study both economics education and social study. The question now says that find how many students that study both econs edu and social study. If we are to work this, how do we solve this? A question says, out of 32 students in a classroom, 32 students in a classroom of economics education or social studies, or both. If 16 students study economics education, 18 students study social study, 3 study none of the courses. 3 study none of the courses. Find how many students that study both economics education and social studies. The first thing to note here in this our solution is that let the number of students who study both courses, let the number of students who study both courses be y. Let the number of students who study both courses be y. Then we now move forward. Economics edu, which is EE, equals to what? 16. Social studies equals to what? 18. None equals to 3. Representing this with a Venn diagram, we have this. Social study, we have economics. How many students study economics? 16. That will now give you 16 minus x. Sorry, y. Y study both. Y study both. Oh, don't let us use this shape. Let's use this shape. Let's use this. Now, we have this circle like this. We have economics education, social studies. Or you put it here, social study. Now, 16 study economics education. 16 minus y. Y here study both. In social study, 18 minus y. Y none study either of the two or neither of the two. None study neither of the two. Now, and the total number is what? 32. You now say 16 minus y plus 18 minus y plus 3 equals to 32. 16 plus 18. 16 plus 18, 34 plus this 37. Minus y plus y will give us nothing. Then we have minus y equals to 32. Minus y equals to 32 minus 37. Which will now give us minus y equals to 32 minus 37 minus 5. Sorry, minus 5. Minus cancel minus. That means our y equals to 5. That means our y equals 5. Y equals 5. That means 5 students study both courses. This means that 5 students study both courses. 5 students studies both economics education and social studies. That means 5 students study both. 5 students study both economics and social study. If you are now to look for how many students study economics education alone, you will now say number of students that study only econs edu will now give you 16 minus y, where y equals to 5, you now say which equals to 16 minus 5, which equals to 11. That means 11 students study only economics education. How many study social study? You now say social study 2 equals to 18 minus what? Y, which equals to 18 minus 5, which equals to 13. That means 13 students also study social studies. So that means 11 study economics, 13 study social studies, 5 study both, none study neither of the two courses. 11 plus 13, 24, plus this, 29, plus this, that will give us 32, which equals to the total number of students we have in the classroom. So that 32 equals the total number of students we have in the classroom. This shows that our answer for y equals to 5 is correct. If our answer is not correct, we wouldn't have gotten this when we solved it. We wouldn't have arrived to 32, which is the total number of students in the classroom. Thank you.